the following piecewise function. Do you remember what the graph of 3 looks like? Horizontal line. Yes, very good. And so if you remember what we did to graph piecewise functions is you would plug in the x value and you would get a y value. So I have negative 1, 3. Open or close circle? Everybody okay with that as a graph? Anybody know what kind of graph is made by the second piecewise function? It's just a point because it's just at x equals negative 1. The function value is 1. It makes sense to you that that is a point. And then finally, x squared plus 2, what does that look like? A parabola. So we plug in negative 1 and you get 3. So if I plug in negative 1, I get 3. Open or close circle? Open. And it'll dip down to 2 because it says x squared plus 2. And that's the graph of my piecewise function. So, this is a nice review of graphing piecewise functions. Now let's identify the limits. Identifying the limits should be easy once we have the graphs constructed. Limit as x approaches negative 1 from the left. As x approaches negative 1 from the right. As x approaches negative 1, does that exist? We have some differing opinions, and we have a question, I think, from Kelsey. Please ask. So the limit as x goes to negative 1 would exist if it's the same from the left as it is from the right. And so it is 3. But what is f of negative 1? If you actually plug in negative 1, you get 1. So the limit is 3. The function value is negative 1. Better? Okay. How about as x approaches 0 from the left? 2. 0 from the right. So does the limit exist as a whole? And the function value is? All right. Now, I know that you guys wanted to extend your learning even further by trying to remember about logarithmic and exponential functions, right? So do you remember what the graph of e to the x looks like? So we are going to look just for the x values that are less than 0. It is the exponential function. If I plug in 0, what is anything to the 0 power? Open or close circle? Is everybody okay with that start? 1 minus x squared, what does that look like? Yep, shifted up 1 unit, right? So that's what I'm going to graph, but I'm not going to graph all of it. I'm only going to graph the endpoints and connect in the middle. So I plug in 0, and what do you get? 1. And then I plug in 1, and you get 0. So we start with a closed circle, and then we go to an open circle. Is everybody okay with that? What does the third graph look like? Right, but because it's just at one x value, it will create a dot or a point, yes. So 1, 2. And then negative 1 plus the log of x. Negative 1 plus the log of x. Do you remember what the log of x looks like? It's basically the inverse of the exponential function. So it would look something like this. But it's shifted down how many units? Okay, so let's plug in 1. When you plug in 1, anybody know what the log of 1 is? That means 10 to what power is 1? 0. 10 to the 0 power is 1. Plus negative 1. Very good. So that's where it starts. Open or close circle. So that's a little bit more involved in piecewise function, I'll admit. The nice thing is you have learned all of that information before. I know that putting it together is difficult, but hey, we want to do AP calculus, right? So got to examine everything. So now let's do the limits. The limit as x goes to 0 from the left. From the right. Does the limit exist as a whole? What is f of 0? How about as x approaches 1 from the left? 1 from the right. Does the limit exist as a whole? Why? Because it's not the same from the left as it is from the right. Okay. Are we past that point? Is everybody confident with saying that in order to check to see if the limit exists as a whole, you have to look at the left and the right? Okay, and then f of 1, 2. So this should hopefully tie together any questions and concerns that you've been having about limits. Is the clock correct? We have 10 minutes to lunch. You're ready for your assignment. That's it, folks. And you got a work day tomorrow. And the answer key is up here and it's posted online. Tell me I'm the best teacher ever. Well, thank you.